Hello students, welcome back to my channel Learning Physics with Bhavya ma'am. Today we are going to discuss about 2 marks questions of Model Question Paper 1, 24-25. So the questions are like this. The first one, state and explain Gauss law in electrostatics. So it is from first chapter. So the answer is the total electric flux through any closed surface in free space is equal to 1 by epsilon naught times the net charge enclosed by the closed surface. So here this is a statement. Statement which carries 1 mark and explanation is 1 mark. So the explanation is, we can write mathematically that electric flux which is phi, electric flux can be written as phi, which is equal to integration of E dot ds, both are vector E dot vector ds is equal to 1 by epsilon naught into q, where q is a net charge enclosed by the surface, epsilon naught is absolute permittivity of free space. Students, please note down the answer. The next question is, define drift velocity and mobility of free electrons in conductors. Very simple question. So the drift velocity is average velocity with which free electrons in a conductor get drifted in a direction opposite to the applied electric field. And mobility is a ratio of drift velocity acquired by the electron per unit electric field. So it is a ratio of drift velocity Vd divided by electric field. It is called as mobility. It is denoted by mu. This is one of the important questions. Please note down. The next one is, there is one long air core solenoid of 1000 turns per unit length, carries a current of 2 ampere. Calculate magnetic field at the midpoint on its axis. So magnetic field at the center of the solenoid is given by the expression B is equal to mu naught Ni, right? So mu naught is 4 pi into 10 to the power minus 7. We know that mu naught by 4 pi is equal to 10 to the power minus 7. That's why we can write mu naught as 4 into pi. Pi is 3.14 into 10 to the power minus 7. N is number of turns per unit length. Small n is 1000 turns per unit length. So that is 1000. N is 1000 into current is 2 ampere. Calculating, we will come to know that it is 2.512 into 10 to the power minus 3 Tesla. The next question is, give the principle of AC generator. Why is the current induced in an AC generator called alternating current? Please understand the question properly before answering. The first question is, give the principle of AC generator. So AC generator works on the principle of EMI. AC generator is also called as AC dynamo. It is based on the principle of EMI. So first question carries 1 mark. Next one, why is a current induced in an AC generator called alternating current? What is alternating current? You should note the definition of alternating current. So in alternating current, the value of current changes its magnitude continuously, right? Magnitude is increasing, reaching maximum, that is called as peak value of current, and decreases to 0 in one direction. Then its direction changes and once again same value repeats. That means the value increases to maximum, called as peak value I0, and decreases to 0. So we know that this is a graph, right? So it increases to maximum, decreases to 0 in one direction and reverses its direction. Again increases to maximum, decreases to 0. So this is called as one cycle of AC. So since the current reverses its direction in every half a cycle, so it is called as alternating current. That is the answer. Okay. Write any 2 uses of ultraviolet radiation. You can write any 2 uses. Okay. Whichever you know, you write that. And please go through X-ray, gamma rays, and other rays, microwaves uses, which is very important. And in EM waves, you please go through the scientist who discovered this. Okay, so that is important question asked in 2 marks. So right, any two uses of UV radiation, it is highly focused UV radiations are used in eye surgery, and UV rays are mainly used in sterilization of air, water or surgical instruments. Name the objective used in refracting type telescope as well as reflecting type telescope. Students, this is one of the important questions. In refracting, as the name suggests, refracting means refraction which takes place. See, refraction means it always takes place in lenses or in prism, right? In telescope, we are mainly using lenses. You know that telescope which consists of objective and eyepiece, which is mainly using objective and eyepiece are lenses. So, which is convex lenses. That's why objective used in refracting type is convex lens, and reflection takes place through mirror, right? So, that's why it is concave mirror. Reflecting type is a concave mirror. Next, write the two conditions for the total internal reflection to occur. Student, this is one of the important question. So, you have to practice this properly. The ray of light should travel from denser to rarer medium. This is very, very important. Okay, if you forget to write this, you won't get mark. Okay, if you write rarer to denser, it is wrong. So, the ray of light must travel from denser to rarer medium. The angle of incidence in the denser medium should be greater than critical angle. So, I must be greater than IC, or you can simply write C. C is a critical angle or IC is a critical angle. So, angle of incidence in the denser medium should be greater than critical angle. These two are very important point, so that these two are the condition to have total internal reflection. Name the majority charge carriers in N-type semiconductor. Majority and minority charge carriers in N-type semiconductor. N-type semiconductor means here the majority charge carriers are electrons and minority charge carriers are holes, right? And it is easy to remember like this. N stands for negative. So, just remember like this, negative. So, negative electrons are majority carriers in N-type. Okay, so if majority is electrons means then which is a minority? Of course, it is holes, right? Or see, in p-type semiconductor, P, you can easily remember like this. P means positive, right? P is positive, just to remember, okay? So, P is positive, which is positive? Holes. Holes are positive. So, in p-type semiconductor, majority is holes, then which is left? Electrons. Electrons are minority. Is this clear for you? So, N-type, you just remember it is electrons, negative. N stands for negative, so electrons are majority. P stands for positive, so in p-type, majority is holes. Is this clear, students? So, N-type and p-type are two types of intrinsic, these two are the types of semiconductor, extrinsic semiconductor. So, just for remember, you can use like this. N means negative, P means positive. Like this, you can remember like this, so that it will be easy for you, right? So, these are the questions asked in model paper 1. Okay. So, I have written all the solutions. Please go through this. Note down all the answers. Okay. Write down in your book, so that while doing the revision, you can just go through this. And the link of PDF is given. Just go through the PDF link. Note down the notes. Okay. Thanks for watching.